So again, let's continue with the last video. The uses operator actually just help you to automatically add your push and pop in the right order. So remember earlier we showed you your array sum procedure. You need to push EXI, push ECX. Then don't forget when you pop, you need to do a reverse order. So you push ECX later. So then you pop ECX first, then pop ESI. But when you're using the uses operator followed by the register name, so they will the Maxent will automatically generate the push and the pop instruction. So you don't need to worry about that. So uses operator will equivalent to when you do the push and pop manually. And the most important thing, remember, when you do your push and the pop, you always need to do the reverse order. So you need to make sure you save and restore register when they contain important value. But the push and the pop instruction, they will be in the opposite order. So that's why earlier we show you in the array sum, we need to restore the parameter value. You need to use the push and pop, or you can use in the uses. However, here because we're using the ECX and ESI is the receive. So that's why we do the push and pop. But be careful when you do the return value. Your EAX is you are expecting the value will be changed. So that's why you need to be careful. All the receive, you can do the push and pop. But when they do the receive, right? So you never push the return value into the stack. Otherwise, you will be in trouble. So that's why be careful about that. So after you understand the procedure, actually in this video, what we want to do is, we are not only show you the push and the pop, we will show you the push add and the pop add. And also one thing is, we will introduce a couple more Irvine 32 library procedure to help you to use that in your homework assignment. So the first one, let's talk about dump memory procedure. So after you include Irvine32.inc in your source file and use our COMSC260 chapter 3 or chapter 5 project, so then all the Irvine32 procedure you can use for that. So another procedure we want to introduce is we call dump memory. So the dump memory is what? Did you remember in chapter 3 when you want to see the content of the array from chapter 3 or chapter 4, when you want to see all the content, all the element in the array, actually we cannot do watch window. We need to go to the memory window. But now, if you call the dump memory procedure, they will write a range of the memory to the console window in the hexadecimal. On the other hand, you just need to tell them which array you want to see and how many elements in the array. And you want the array is 1 byte, 2 byte, or 4 byte. Then they will display the result in console. So here, before you call the dump memory, they require 3 registers. The first register is ESI, pointing to the beginning of the array. So then you have ECX. So they will pass the number of the element in the array. So then the EBX, you just let them know the size of each element. So 1 is 1 byte, 2 is word, 4 is double byte, or double word. So that's why they can display the value. So that's why we try to show you before you call your dump memory. Okay, so here actually is the most important thing before you call the dump memory. You need to move your ESI is, for example, we already defined, we have the double word value. So they have 1, 2, 3, 4, 5, 6 elements. So the location for the array move to ESI. So then your ECX is the length of the array. So the EBX will be the type of the array element. So that's why you don't need to give them 1, 2, or 4. You can just use the type. So then you will call dump memory. Right, so you see here, right? You have your ESI, ECX, EBX. So then actually when you call the dump memory, they will push those registers in the those ranges in ESI, ECX, EBX. So then they will pop EBX, ECX, ESI in the reverse order. Okay, so that's why here supposedly you don't need to do that in your code when you code dump memory, but here we just show you this actually happened. Okay, so let me show you. Okay, so that's actually the orange color. So here we just want to show you they are in the reverse order, but actually those things is already happening in the dump memory procedure. So that's why here when you want to try it, you only need to write the purple part. So then you will see here they will have the value display like that. You see you have 6 elements. They display in the hex format. So sometimes you can see you have the ranges you can push one by one. Or the other one we want to show you is you have another instruction called push AD. So actually they will push all the 32-bit general purpose registers on the stack in the following order. So then you can have pop add instruction, pop the same registers off the stack in the reverse order. So then here, so sometimes when you implement your procedure, if you do have a lot of the registers you want to push, so instead you just push one by one. You can use the push add or pop add. So they will from using the specific order to either push them to the stack or pop them from the stack. So the next example will show you we have a dump regist. So that's another procedure defined in the Urban32 library. When you call the dump regist, they will display all the regist information in console. For example, you see here, when you push add, push all the registers into the stack. So then you call dump regist. So that's why you see they display all the registers and even the status flag. So now let's change the value. If you change the EAX, EBX, ECX, EDX value, you call the dump regist again. So that's why you see here, the value changed. So then again, earlier we push add, right? So that's pop add. So we restore the value, the regist from the stack. So then you call dump regist again, you will see they will be the same as before. So the dump regist actually is the other procedure, but this procedure will display not only all the regist value, they also show you the status flag. So quickly, let's show you another two example, another two procedure. The first one we call ReadInt. So this ReadInt procedure, they will save the user input into the EAX. So the WriteInt, you will save the value in EAX. So then they will display the value saved in EAX. So for example, you see here, we just ask user to enter one signed integer. So in order to display this, right, don't forget we can call write string, right? So the write string, we display the information from the EDX. So we have the offset from the string we want to display in the EDX. So then we call write string. So the write string, they will say, please enter one signed integer. So then the user will enter positive 58, right? So then you just call ReadInt. So they will save this positive 58 in EAX. So then since you already saved this value in EAX, right? So then if you try to call WriteInt, so then you see 58 being displayed again. So that's to read and write example procedure from the Urban32 library. They're using the EAX as a regist. So the same thing on Tuesday, we talk about write string and the read string. So they're using the EDX to refer to the string array, the byte array they want to display. So when you watch the video, if you have any question, please make sure you will ask in the Zoom meeting and write it down. And also, we don't have time to show you all the example. But one thing is, when I list the example in the lecture file. For example, like earlier, we have the array sum procedure. So don't forget here I have the test array sum.asm file. You need to make sure you will download that and try to run from your IDE. The end of this video, I will show you the last procedure you will use for your homework assignment. So this procedure we call RandomRange. So this RandomRange procedure actually already been defined in the Irvine 32 library. So how you would use that, you just call RandomRange. So the RandomRange procedure actually produces a random integer within the range from 0 to n-1. So this n actually can be any positive sign integer, or it actually should be unsigned integer because the n just n-1. So we don't have negative or positive, so that's unsigned integer. It's any value. So this n you need to save in the EAX. So before you call RandomRange, you want to, for example, you want to generate a number between 0 to 500. So then 500 actually will save in EAX. So then here, if 500 equal to save in EAX, they will generate the number start from 0 to 499, not including the EAX value. So you need to save your range in the EAX. Then one thing is, after you call the RandomRange, the random number that also is in the EAX. So be careful, EAX can be the input and also they will be the return. So here, if we want to display the value, you can using the WriteInt procedure to display the value. So we see, for example, you want to generate a random number between 0 to 4,999, and you want to display the result in the screen. So how you will do, you just have here. You move your EAX with the 5,000. Then you see EAX at 5,000, right? So you call RandomRange. So then the random number will save in the EAX. So then you just right away call WriteInt. So then you will display the value, the random value. So they will display the random value in the console. Okay, so after you understand this one, how about we try to generate a random number for a few times? So then we see this example. We know how to using the call RandomRange, but now we are not only I want to generate and display the sign integer between 0 to 99, and also I want to do that for 10 times. Yeah, so that means correct earlier I say. So here actually your RandomRange, they did have the sign. So that's why here the n actually is the sign integer. So even you just move each AX equal to 5,000, but here they will consider that the positive 5,000. Also because earlier we say the WriteInt and the ReadInt, they will process the signed integer. Okay, so remember here, in our ReadInt and WriteInt, they will process the signed integer. Okay. So then the same thing, when you display, they also have a signed integer. So on the other hand here, when we do that, they will display the signed integer. So now how we will do that for 10 times. So then here we will do for 10 times. So that's why you will see you move ECX is 10. So then you will have your value, because I want to display 0 to 99. So that's why I have the EAX equal to 100. So then I call RandomRange. So you see the RandomRange will generate a random number in EAX. Then you call WriteInt right away, they will display that. So don't forget, we want to display one at a time in each line. So you call CRLF, they will have the new line. So then don't forget you doing the 10 times, so you have a loop. So here our loop. After we done the display, we just go back to the loop. So then we will do 10 times. So you will see here, they display the 0 to 99, the random number 10 times.